solving equations, application of solving equations. We have been learning how to solve a system of two equations, and so we have learned three methods for solving them. Now we are going to see where these system of equations would come in real life problems, which means learning to solve word problems. I know many of you don't like word problems. I have heard students saying, I hate word problems. It's a very common statement from students, but if you hate them, then should we not teach them? Well, no. The reason for teaching, even teaching application problems, is because that's the purpose of learning math. How to apply them in real life problems. If I don't teach you the application problems and just teach you how to solve the system of equations, there's no use of it. It's like showing you what a hammer looks like and what a plier looks like without telling you how to use it to achieve something. There's no use of it. So that's why you have to learn how to apply them to solve real life problems. Only then you are using that knowledge, the ideas you learn. So I've been very successful in teaching students how to solve word problems, even though they hated them before. So let's try it and see. So to do an application problem, you have to read the words and identify the unknown quantities first. There are usually some unknown quantities that you need to determine the value of. And when you identify the unknown quantities, you need to assign some names to that, like X, Y. We usually use letters X, Y, Z for the unknown quantities, and you use those variables to identify them. It is usually helpful to write down what X is, what X represents, and what Y represents, and then proceed to read again and identify the equations. There are statements that will translate to equations, and you need to identify them. So I'm going to begin with simple statements that translate to mathematical expressions. I'm going to show you some of those. This is a better way to see how to translate a word problem into a system of equations. So let's start with the translation of verbal statements into mathematical expressions. So if a statement says 5 more than an unknown number, then you introduce the name X for the unknown number, then 5 more than that number will be X plus 5. 10 less than a number, so you identify the number as Y, then 10 less than that will be Y minus 10. Double of a number will be 2 times X. X is the unknown number, 2 times X will be double. Half of a number will be X over 2 or half times X. 2/3 of a number is 2/3 times X, which is same as 2X over 3. 15% of a number is 0.15X. To find 15%, you multiply by 15 over 100. The 15 divided by 100 is called the decimal form of 15%. And that decimal number multiplied by X will be 15% of X. 3% of a number will be 0.03. 3 over 100 is 0.03, so 0.03 times X. So this is how they translate, simple statements. And we'll proceed to understand more of them. So whenever the problem says some quantity is the same as another, then it'll mean equal. The first quantity is equal to the second. So you introduce the equal sign. Usually in verbally stated problems, the word is, usually something is same as the other, and they would use that word is, and is translates to equal sign. I'm going to show you an example. Let's translate the statement, one number is 5 more than another. One number is 5 more than another. Here, one number we will identify by X. The word is here is going to translate to equal sign, equal to 5 more than the other. So the other number, you introduce the name Y, then 5 more than the other is Y plus 5. So therefore, the one number, which is X, is equal to Y plus 5. So the word is translates to equal sign. So here's the complete statement. One number is 5 more than the other, is same as X equal to Y plus 5. So it's, if you just dissect the whole statement, you can easily translate that. Basically, this whole idea here is to translate the word problem, the verbal statement, into mathematical expression. So let's see some more examples. One number is double the other. So one number will be X, double the other is 2Y. The word is translated to equal sign. One number is equal to twice the other. One number is 10 less than half the other. So here's one number. Here is half of a number, and subtract the 10, that'll be 10 less than the other number. Let's look at the next one. Difference between the numbers is 7. So difference between the numbers will be X minus Y. The numbers are X and Y, difference is X minus Y. So X minus Y is equal to 7. The word is translates to equal to, is equal to. Double of one number is 5 more than triple of the other. So double of one number will be 2X. 5 more than the triple of the other is 3X plus 5, or 3Y plus 5. You have to introduce different name for the two different quantities. That's 3Y plus 5. The word is translates to equal sign. Yearly interest is 4% on one investment, 11% on the other. Total interest is 341. That means you had to calculate 4% of the first investment, which is 0.04 times X, 11% of the second investment, 0.11 Y. Sum of those will be the total interest, and that would be equal to 341. So 4% of first investment plus 11% of second investment equal to 341. If you just carefully look at it closely, you will be able to see how to translate it. Okay, so let me see if you can translate these now. If you have printed your worksheet, I would recommend writing your answers underneath each problem. So I'm going to give you a minute to do some of them. Go ahead. Okay, so anybody has the answer to the first question?
Yes.
So 2x plus 3y equals to 45.
2x plus 3y equal to 45. Very good. That is correct. Everybody see it, or anybody needs explanation? Double of one number, 2x. Triple of the other, 3y. They add up to 45. Sum of them equal to 45. That's it. Okay, going to number 2. Okay, if everybody has the answer, go ahead.
6x plus 4y equals to 764.
Okay. write an equation relating the number of each kind. Okay, that's right, very good. The number of each kind of tickets sold is the unknown quantity. Usually the last line tells you what the unknown quantities are. I'm explaining for everybody, but that answer is correct. So basically, the number of each kind. So X represents number of $4 tickets or $6 tickets sold, number of $6 tickets. And Y represent number of $4 tickets. Then X is the number of $6 tickets, and each $6 ticket brings in $6. So you have to calculate the total money that brings in, all the $6 tickets bring in. So each ticket is $6. I'm selling X number of them. So let's think in terms of a fixed number. If I sell 10 tickets at $6 each, how much money do I collect? $6 times 10, right? That'll be $60. In the same way, I had to work with the X and Y, unknown quantities. So if I sell $6 tickets, X number of them, the total money I collect is 6 times X. Like, multiply the number of tickets times the money from each. So that's why 6X represents the money you collect from all the $6 tickets. 4Y is the money you collect from all the $4 tickets, Y number of them. So add them up, that's the total money collected, equal to 764. Okay, going on to number 3. A rectangular field of unknown length and width has perimeter equal to 864. Write the equation relating the length and width. So the length and width are unknown. So let me put a little picture up here. Length and width are unknown. The word length usually refers to the longer side. It doesn't really matter which is length, which is width. So let's say this is length and I decide to call it X. Width, I'm calling W. Doesn't matter what names you use. You can use X and Y if you like. So they are the unknown quantities. Length and width are unknown. And it says the perimeter is 864. Perimeter is the total measure around the rectangle. So what would be the equation that relates length and width to the perimeter? Anybody?
2x plus 2y equals to 864.
Right, very good. 2 students answered it at the same time. You're right. 2L, I'm using L and W. So 2L is that's because there's the opposite side to this L is also equal to L. Similarly, this is also equal to W. Perimeter will be total measurement around it. So L plus W plus L plus W, which is equal to 2L plus 2W, and that will be equal to 864. That's our equation. So perimeter is 2L plus 2W always for any rectangle. Area of a rectangle will be L times W, length times width. Now here they're talking about perimeter. Okay, going on to number 4. A retired couple invested in 2 different accounts. One mutual fund that pays 6% interest. CD pays 3% interest. Their interest income for last year was $1420. For the whole year, interest income was $1420. So write the equation. Anybody?
Um,
0.06x plus 0.03y equals 1420.
Equal to 1420, right? Very good, excellent. That is correct. That's because if I call the first investment, the investment at 6% as X dollars, then 0.06X is the income from that for a year. The 6% interest rate is 6% means it'll pay you 6% per year. So if you calculate if you multiply X by 0.06, that's the interest income for a year. Similarly, interest income from the other investment is 3% of Y. If I add them up, it has to be 1420. That's our equation. So that's very good. many of you were able to answer them. Let's go on to setting up and solving equations. If there are two unknown quantities, then the information will be translating to, in a problem, if they expect you to find a solution, then they have to give you two equations if there are two unknowns. We have seen in the past class that if you have one equation in two variables, then there will be infinitely many solutions. So in real life problems, we expect one solution for the problem. So there must be two equations. Only if there are two equations in two variables, there will be a unique solution. So in the word problems that we're going to do here, there will be two equations in two unknowns, and you need to find both of them. And then you have the system of two equations ready, and then you had to go ahead and solve them by using one of the methods we learned in the previous class to find the individual values of x and y, the unknown quantities. So you had to find the unknown quantities and then interpret them. In other words, exactly what they represent must be used to answer the question. For example, if they say, determine how much was invested in the 6% rate and how much was invested in 3%, then you call them x and y and set up the equation, solve them. At the end, you had to present the answer as so much was invested at 6% and so much was invested at 33%. That's how you answer them. Don't answer in terms of x and y. X and y were introduced by you, so the answer should not talk about x and y. It should talk about what they represent. That's how you conclude your solution. Okay, so let's start solving some example problems. Perimeter of a floor. Let me clear the screen. Okay, it says perimeter of a rectangle. Rectangular floor is 90 feet. Find the length and width of the floor if the length is twice the width. So there are two pieces of information given to you here. Perimeter is 90 and the length is twice the width. So you have to translate them into two equations. Don't try to translate them all into one equation. Very often students do that. And when you do that, you tend to make mistakes. In all of these problems you're going to do, translate the equations into, translate the facts and the statements into two equations always. So here the question is basically what are the length and width. So the perimeter is given, that's going to be one equation, and the other information is length is twice the width. But I'm going to individually call them x and y. Length will be x and width is y. Then the perimeter is 90. That easily translates. We did that earlier. So can somebody tell me what that first equation is?
2x plus 2y will be equal to 90.
Right, very good. Thank you. So that's our first equation. And second piece of information is length is twice the width. Now remember the word is translates to equal sign in a statement like that. So length, which is x, is twice the width, means it's equal to 2 times y. So always write the two equations like this. Some students try to use both information into one equation. Don't do that. So this is my second equation. Now I'm going to solve them. To solve them, in this case, substitution method is easier because the second equation is solved for x already. It says x equal to 2y. So therefore, I can substitute the 2y in for the x, and that'll give me 2 times 2y plus 2y equal to 90. And this is 4y plus 2y equal to 90. So 6y equal to 90. And divide by 6, that'll give you the y. So so the width is 15, and now to find the x, I can plug it into any equation. I'm going to plug it into the second equation. which says x equal to 2y. So 2 times 15, which is 30. So you conclude by saying length equal to 30 and width equal to 20. Now in the WebAssign assignments, it'll have boxes to enter the answer for each one, and it'll say length, and then it'll have a box, and then it'll say width, and it'll have a box. So you don't need to write these, you're entering the answers in this case. But if you're doing it on a paper in a test, you're expected to write the conclusion this way. All right, let's go to the next one. I'm going to clear the screen first. Okay, second problem says, a piggy bank contains 82 quarters and dimes worth 11.80. How many quarters and how many dimes were there? Okay, then I'm going to call the number of quarters as X. Oh, hold on, someone came in. Maggie Gomez. If you have come late, remember the attendance policies. You know, if you miss more than 15 minutes of the class, then you don't qualify for the first reward. If you miss more than 1 hour and 15 minutes of the class, then you don't qualify for the second reward. So these latenesses and missed classes are all accounted for, and they will affect your reward. So therefore they will affect your grade indirectly. So I recommend having perfect attendance and receiving both rewards. Then you will be doing, you will be learning better and you will be doing better. All right, so number of quarters is what I'm going to call X, and number of dimes equal to Y. It says there were 82 quarters and dimes. In other words, 82 is the total count of how many quarters and dimes were there. So that's the total count of the coins. Okay, so can somebody tell me what that translates to?
X plus Y equals to 82.
Right, X plus Y equal to 82. Because X is the number of quarters, Y is the number of dimes, X plus Y will be the number of coins altogether, total number of coins. And that's what 82 is. So that's our equation 1. Then it says the money is worth, the amount of these quarters and dimes are worth 11.80. So that's the monetary value of those coins equal to 11.80. So I had to translate the number of quarters and number of dimes into value. So these X quarters will have how much value in dollars. Every quarter has how much value as in dollars, the dollar value.
0.25.
$0.25. That's right. So X quarters are there. So what's the value of that? Anyone?
0.25x.
0.25x. Each quarter is worth $0.25. So X quarters will be worth 0.25x. Similarly, what's the value of the dimes? Anybody?
0.10.
0.10 times
Y.
Y. There are Y number of dimes, and each dime is worth $0.10, and therefore 0.10Y is the total value. So when I add them up, that's the total value of all the quarters and dimes, and that's equal to 11.80. I converted everything to dollars. You could have converted everything to cent if you like. So if I wanted to do that, instead of doing this, then it'll be 25 cents is the value of each quarter. So if I write 25 times X, that's the coin, the value of the coin in cents. As long as you keep track of them and you keep the unit the same throughout, you'll be fine. So this will be correct if you convert them to cent. 25X is the cent value of that money, and the dimes, 10 cents worth each time. So y times are there. 10y is the cent value of that money, equal to, now on the other side also I had to write cents. $11.80 is equal to 1,180 cents. You had to multiply that by 100 to get the cent value. So now this equation is essentially same as the second equation we wrote here. Both are essentially same. So it doesn't matter how you do it. Whether you translate to cents or dollars, doesn't matter. And even if I write the equation this way using dollar value, then to eliminate the decimal points, I had to multiply by 100 to eliminate, you don't want the fractional numbers. So you want to get whole numbers. Excuse me. So to convert the equation to have whole numbers, I had to multiply throughout by 100. After multiplying by 100, I get this equation. This equation is what I get. So therefore, it really doesn't matter whether you convert them to dollars or cents. Anyway, I have two equations. To solve, I can use elimination method. I can eliminate the x by multiplying first equation by minus 25, or I can eliminate y by multiplying by -10. But you already learned how to solve, so I'm going to focus on setting up the equations. But in your homework, you had to set up and solve the equation to find the answer. So this was number 2. All right, so let's proceed to number 3. Example number 3. Length of a field is 50 meters longer than its width. And the length of the fence required to enclose the field is 3,000 meters. What are the dimensions of the field? So they're asking for the length and width of a field. So let's say this is the field and the length is X and the width is Y. The first statement here is length of the field is 50 meters longer than its width. So length is 50 meters more than width. How does that translate?
50 plus x is equal to y.
50 plus x equal to y is incorrect because x
It's
is the, go ahead.
X is equal to 50y.
X equal to 50y? You mean 50 times y?
Yeah, that's what I mean.
Okay, that
50 plus y.
50 plus y is the correct way. 50 times, not say 50 times y. If 50 more, 50 longer, 50 meters longer means 50 meters will be added, right? It's more. It's not 50 times. So, so here is how it translates. The length of the field is, right? Length of the field, you have to first write the letter for that. Length of the field is what we call x. So x, you write the x, and now the word is, oops, moved it. The word is here translated to equal sign. 50 more than width will be 50 plus y, or y plus 50. So length equal to y plus 50. What would translate to 50 times? If it says 50 times or width, if it says length is 50 times width, then it will be length equal to 50x. So here it's 50 more, 50 longer. So 50 meters longer is same as saying 50 more than width. So that means add 50. So length equal to y plus 50. That's our equation. Second equation will be the length of the fence required to enclose the entire field is 3,000 meters. So that's essentially saying the perimeter is 3,000. You know, the fence, length of the fence that you need to put around the field is 3,000 meters. Is same as saying perimeter is 3,000. So what would that equation be? Anybody?
2x plus 2y equals to 3,000.
Right, very good. So that's our second equation. And now we have the two equations available. I had to solve them. Which method will be convenient here? Anybody?
Substitution.
Substitution is convenient because the first equation is already solved for y. So you can substitute the y plus 20 for the x in the second equation. So that'll be the easiest way. But I'm not going to solve it. You know how to do that. Moving on to number 4. Movie theater charges $9 for adults and $7 for seniors. One day when 325 people paid for admission, the total revenue was $24.95. That means total money collected was $24.95. And then the other piece of information is 325 people paid for the admission. So 325 people includes adults and seniors. So we don't know how many of each. So that is the question. How many adults and how many seniors paid for the admission? I'm going to introduce the names for them, and then we will work on the equations together. So let's call the number of adult tickets sold as X. Okay, and Y will be number of senior tickets sold. And then it says, let's translate that first piece of information. Altogether, 325 people paid for admission. How does that translate? Anybody?
X plus Y equals to 325.
Right, very good. X number of adults purchase the tickets, Y number of seniors purchase the tickets. So total number of people who purchase the ticket will be X plus Y. And so that's equal to 325 is the first equation. The second piece of information given to us is the total revenue. Total money collected is $24.95. Can somebody translate that information?
9x
9x
plus 7y equals to 2495.
Right, 9x plus 7y, because $9 is the price of adult tickets and X number of them were sold. So total money collected will be 9 times X. Total money collected from the senior ticket is 7 times Y. And if you add them up, that's the total money collected, equal to $24.95. Okay, that's very good. Many of you are able to do them. So let's go to number 5. The Dolphins made 2 and 4 point goals. So certain goals earn 2 points, other goals earn 4 points. So they made both kind of goals, and they scored 66 points altogether on 24 field goals. So the 24 field goals include some of 2 point goals and some of 4 point goals. So we will call number of 2 point goals as X. X equal to number of 2 point goals. And Y will be number of 4 point goals. So then the total points scored was 64 from 24 goals. So the 24 field goals were made. How does that translate?
X plus Y equals to 24.
Right, very good. X is the number of 2 point goals, Y is the number of 4 point goals. Total number of goals were 24, means X plus Y must be 24. That's the first equation. And the points earned is 66. Okay, how does that translate? Anybody?
2x
2.
plus 4y equals to 66.
Right. 2x is the total points earned from all the 2 point goals. X number of them are there. Each one earns 2 points. So total points earned from that will be 2x. Total points earned from all the Y number of 4 point goals will be 4y. The sum of those will be 66. If anybody is not following anything, feel free to interrupt and ask your question. Okay, so number 6.
Question about number 5. So the answer for 5 would be just 2x plus 4y equals 66, or would we need an actual solution?
So you have to actually solve it. I'm showing you how to set them up because you already have learned how to solve them.
Okay.
Okay. But so in your homework, you actually have to solve them and present the final answer. But I'm focusing on setting up because you already know how to solve them. So there's no need to go through the solving process. Okay, I'm at number 6. A retired couple wants to receive 12,000 as annual interest income. So they want to get 12,000 as interest income from $150,000 they have for investing. They chose 2 investment options. AA bond will pay 10% annual interest. The bank certificate will pay 5% annual interest. So the question is, how do they divide the 150,000? You know, how much of the 150,000 should go into 10% and how much should go into 5%, so that the total income is 12,000. So their goal is to make the income equal to 12,000. So that means money invested is going to be unknown. How much money is invested in 10%, how much is invested in 5% is unknown, but the total is 150,000. That's all we know. So we will call X as money invested, dollars invested at 10%. And Y will be money invested at 5%. Okay. Then the total money they invested is 150,000. So how does that translate?
X plus Y equals to 150,000.
Right, X plus Y equal to 150. Always look for 2 equations. Some students tend to translate them into 1, and I don't recommend that. It can be translated into 1, and only you will be doing it right only if you're extremely good at this. And none of you are extremely good at this. So I recommend breaking it up into 2 equations always. Don't try to do it as 1 equation. So X plus Y equal to 150. And now I have to account for the income. So total income earned has to be 12,000. So yeah, can anybody translate that?
So it's 0.1x plus 0.05 multiplied by 150,000 minus x equals to
That's
12.
exactly what I don't want you to do. You're translating into 1 equation. I don't want you to do that. The first investment is X dollars, second investment is Y dollars. So 0.10x is the income earned from the first one, right? And 0.05 times Y is the income earned from the second one. Don't put 150 minus X here.
Equals to 12,000.
Right, equal to 12,000.
And then we can use the substitution technique.
I'm sorry? So,
I think I was using the substitution technique.
yes, you were trying to put the 2 equations into 1 equation. Don't do that. Always write them as 2 separate equations in the 2 unknown quantities. So this second equation is equal to 12,000. Okay, so that's the second equation. Always write the equations as 2 equations. You were trying to replace this Y with the 150 minus X. I don't want you to do that. So we have 2 equations, and now we can solve it by elimination. But the second equation has fractional numbers. So what should I do first for the second equation?
Times by 100.
Multiply by 100, yes. Only then all the fractional numbers will go away. So if I do that, then I'll get 10x plus 5y equal to 12,000, and then 2 more zeros because I'm multiplying by 100. And this will be my new second equation. So it'll be easier to solve these 2. And so that's what you should do. Always eliminate the fractional numbers. All right, I'll leave it at that. And if it is actual,
I have a question.
yeah.
When
Sure.
we're doing like this one with the fractional numbers and we multiply it by 100, when we get our answer, we have to divide it back.
No, 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 no. An equation, when you multiply the entire equation by any number, the new equation is identical to the previous, okay? So this is just another form of that same equation.
Oh, okay.
You're not changing answers. The answers will be same whether you solve these two or these two, okay? The answer doesn't change because you multiply the equation. Because we multiplied both sides, so we didn't change the equation, okay? So you don't divide by anything at the end. The solution you find for x and y will be the answer. So that's number 6, and let's go to number 7. So clear the board. Okay, a store sells, this one is maybe a little bit trickier than the other ones. So let me go a little bit slower on that. A store sells cashews for $5 and peanuts for $2 per pound. So if they sell the cashews directly, they'll be getting $5 per pound. If they sell the peanuts directly, they'll get $2 per pound. But the owner wants to produce a 90-pound mixture of these nuts that can sell at $4 per pound without losing any revenue. That means they want to mix it and sell it at $4. By selling at $4, they should get the same amount of money that they get by selling them individually. So the question is, what should be the mix? You know, how much of how much of cashews should be mixed with how much of peanuts? You know, in what ratio you should mix them to get a mixture that would be worth $4. That'll be selling at $4 to get the same amount of money. So that's our question. So the question is how many pounds of cashews and how many pounds of peanuts to mix, right? So first, always you must read and understand the question, understand exactly what we are looking for, and then identify them by names. So I identified the amount of cashews and amount of peanuts to mix as the question. So I'll introduce names. X will be the pounds of cashews to mix, and Y will be the pounds of peanuts to mix. So when I mix it, I should get 90-pound mixture, and then the value of that mixture selling at $4 should be same as the value of selling individually at $5 and $4. So that's they're going to be the two equations. So one equation is going to be coming out of the fact that the total measure of the mixture is 90 pounds. So how do we translate that?
X plus Y equals to 90.
Right, X pounds of cashews and Y pounds of peanuts were mixed. So X plus Y will be the total weight, and that has to be equal to 90. So that's the first equation. And the next one has to be about the value. The total value have to be equal. So you need to calculate the value of the $5 the cashews, total value of the cashews that are going into the mixture, and total value of the peanuts that are going into the mixture, and set it equal to the value of the mixture itself, selling at $4. Okay, so can somebody tell me the expression for the value of the cashews?
It's 5x plus 2y equals to 4x plus 4y.
Okay, 5x plus 2y is correct for the value of the mixture, and that should be value of the cashews and peanuts going into the mixture, and that should be equal to value of the mixture itself. And did you say 4x plus 4y?
Yeah.
Okay, yeah, that's correct. Basically, she's saying $4 times x plus y, which is right. $4 is the value of the mixture is selling at $4. The total weight of the mixture is x plus y. So therefore, $4 times x plus y is the total value. But if I put the x and y, x plus y there, then my equation is get a little bit more complicated. I don't, this is correct, but instead I want to write in place of x plus y, I want to write 90. I already know that the total weight is 90. So I will write 90 there instead of x plus y. Well, we already know x plus y is 90. So if I put it that way, it'll be easier. So basically my second equation is 5x plus 2y equal to 4 times 90, which is 360. So that's my second equation. 4x plus 4y or 4 times x plus y is correct, but put the 90 in place of x plus y to make it easier. So my equation is now easier to solve. So these two equations can be solved by elimination method. If anybody is not understanding, please feel free to ask me. I can explain again.
Sorry, can you repeat how you got is that 360 or 260?
I'm sorry, say it again.
Oh, I was wondering, can you repeat how you got 360 again?
Okay. Okay, let me explain the second equation again. The value of the mixture is what we are matching. The value of the cashews and peanuts going into the mixture, that will be 5x plus 2y, right? X pounds of cashews were put in the mixture. Each one is worth $5 a pound. So 5x is the total value of all the cashews. The Y pounds of peanuts are going into the mixture. The peanuts are worth $2 a pound. So therefore 2 times Y is the value of that, of the peanuts. So 5x plus 2y is the total value of the peanuts and cashews that went into the mixture. And this should be equal to the value of the mixture sold at $4. They're selling the mixture at $4 a pound. So $4 per pound is the price of selling price. And how many pounds are they selling? 90 pounds. The mixture is 90 pounds, isn't it? So 4 times 90 is the money they're going to collect by selling the mixture. 90 pounds of mixture, $4 a pound.
Okay, thank you.
4 times 90 is what 360 is. Okay,
Thank you.
you're welcome. So that's my second equation, and you can solve them to get the answer. Going over to number 8. So I have selected some good examples, examples that illustrate these different kinds of problems. And so this should be a good collection of examples to get you ready for any kind of application problem. So in the homework, don't expect them to exactly match these problems, but you'll be ready for them if you do all of these. So number 8 is called dieting problem. A woman must go on a diet and allowed to consume only 760 calories. The total calories she can consume will be 760, and total protein she should consume is 28 grams. So she's going to consume those through milk and bagel. Each cup of milk contains 170 calories and 80 grams of protein, and every bagel contains calories and protein. So when they give you information like this, milk has calories and protein, and then bagel has calories and proteins, it'll be helpful to organize them in a table. So protein and calories. So I'm going to write protein as a title. It doesn't matter whether you write it as a column title or row title. Protein and calories. These are the two things we are concerned about. And we are getting them through milk and bagel. So you put the milk as column title, bagel as column title. Like I said, they can be row title. If you switch these titles to row and column, it wouldn't make any difference as long as you remember what is what. Now, each cup of milk contained 170 calories. So 1 cup of milk contained 170 calories and 8 grams of protein, 8 grams of protein. So you put that information there. Similarly, this is per cup. Each cup contains that. You have to remember that. And each bagel contains 140 calories. So go to bagel, 140 calories and 4 grams of proteins, 4 grams of protein. And then it says this individual is allowed to consume only 760 calories. So across the calorie row, this row, the calorie row, you write the limitation at the end here. 760 is the maximum she is allowed to consume. And protein, how much is she allowed? 28. So put that also across that same, across the row where protein is. So now your table is complete. You have all the information. 28, 76, and 760 are the limitations. So what is our question? How many cups of milk and how many bagels is she allowed to eat? So that's our unknown quantity. So the unknown quantities are calorie, the amount of milk and bagel she's allowed to eat. So we're going to introduce variable names for them. And so you put those variable names right there about the milk. The milk, X cups. That's unknown quantity. You call it X cups. Number of bagels, Y. Y is the count of bagels. So those two are the unknown quantities. If you put them on the table at the top there, then it'll be a lot easier to understand your table. Now let's write down the equation. Protein, let's look at protein. The amount of protein that you get from each cup of milk is 8. How many cups is she drinking? X cups. So how much of protein do you get from all that milk? Anybody?
8x.
8x. You get 8 protein from each cup. You're drinking X cups, so 8x is the total protein you get. Similarly, the protein you get from the bagel is 4. 4 from each bagel. You're eating Y number of bagels. So total protein from that is 4Y. And if you add them up, you get the total protein from both foods. And that should be equal to what?
28.
28. Total protein you eat must be equal to 28. Now go to the calories. You get 170 calories from each cup. You're drinking X cup. So 170X is the total calories plus what?
140.
140Y must be equal to 760.
760.
Right. So now you have set up total protein consumed equal to allowed protein 28. Total calories consumed equal to allowed calories 760. And your equations are done. And so after that, you can solve. So as you can see, organizing this information in a table is important. So when they give you this kind of information, every cup of milk has so many calories and so much protein, and then bagel has so many calories and protein, that right there calls for table. So organize the information, then it'll be easier. If you don't organize, it will be extremely hard to set that up. So I'm going to clear the screen and go to the next question. Okay, so next one is 3 cartons of milk cost you 89 more than 1 carton of corn. And then 2 cartons of milk and 3 cartons of corn together cost you 21.53. So what are the prices of the carton of milk and carton of corn? So the question tells you exactly what the unknowns are. So we will identify them by names. The number of cartons of, the price of a carton of milk. So X will be the price of carton of milk. And Y will be the price of corn. carton of corn. Okay, 3 cartons of milk will cost you 89 more than 1 carton of corn. Right there, that will translate to one equation. 3 cartons of milk. Now, X, X is the price of carton of milk. So 3 cartons of milk will cost you 3X, right? X is the price of each carton. 3 cartons of milk will be 3X is the cost. And that will be 89 more than 1 carton of corn. So what's the equation?
3x is equal to y plus 89.
Y plus 89. Very good. So the 3 cartons of milk has this cost. 1 carton of corn has Y cost. So this is 89 more than 1 carton of corn means this equal to 89 more than Y. 89 more than Y is 89 plus Y. So that's how you translate that. That's one equation. And the second one is 2 cartons of milk and 3 cartons of corn together cost you $21.53. Total cost of 2 cartons of milk and 3 cartons of corn is $21.53. Anybody?
2x plus 3y equals to 2153.
Right. Very good. 53, that is. Okay. Very good. Those are correct. Anybody has question? Feel free to ask the question. To solve, you can use substitution method. Then you have to divide by 3. If you divide by 3, you're bringing in fraction. So if you don't like that, then rewrite the first equation as 3x minus y equal to 89. Then you can use elimination method now. So to use elimination method, you have to rearrange the first equation. Okay, so let's do number 10. A coffee manufacturer wants to make 100-pound blend of coffee. Now we have done different kinds of problems already. These are additional questions now. This one is similar to an earlier problem. Coffee manufacturer wants to make 100-pound blend of coffee that'll cost $4.60 per pound. So the blend should sell at $4.60. And to get that, he's mixing 375 coffee, the one that sells at $3.75, and the one that sells at $8 per pound. So how much of each should be mixed is the question. So we can introduce the name X and Y. So X will be the amount of, or pounds of, the coffee that sells at $3.75. Y is the pounds of the second coffee that normally sells at $8 a pound. That's what we are mixing. And our mixture should be 100 pounds. So that immediate equation comes out of that would be?
X plus y equals 100.
Right, very good. So that's one immediate equation. And the other one is going to be about the value. The total value of the coffee should match the amount, the value of the original mixture should be same as the value you get by selling them. So X pounds of $3.75 coffee and Y pounds of $8 value coffee are mixed. So what's the total value of those coffees together?
3.75x plus 8y equals to 4.6 pounds multiplied by 100.
4.6 times 100. That's right. Very good. So the mixture is, this is the total value of the coffee going into the mixture. And then now the mixture is going to sell at $4.60 per pound and 100 pound is being sold. So 460 times 100. That's the total value you get, your total money you get by selling them at 460. So that's my second equation. So Well, I can rewrite the second equation as 3.75 x plus 8y equal to 460. 460 times 100 is 460. So now you can solve them by elimination. If you want to eliminate the fraction, you can multiply by 100. That'll make the numbers huge, but you can actually keep the numbers this way because they're not all fractions. Only one number is fractional. I would keep the numbers this way and use elimination method and eliminate y. To eliminate y, I will have to multiply the first equation by -8 and then add them up. And I would recommend doing that. Eliminating the fraction here will make all the numbers larger, too large. I wouldn't recommend that. But if you feel comfortable doing that, you can do that. It doesn't matter how you do it. Okay, so last problem we need to do is number 11. And this is also similar to a problem we did earlier. So let me clear the board. Okay, a doctor prescribes a patient to consume 40 milligram of vitamin C, 30 milligram of vitamin E. So that's how much of vitamin C and E the patient should consume. The pharmacy stocks 2 liquids that can be sold, that can be used. One of them contains 20% vitamin C. Okay, so I'll call them liquid 1 and 2. They didn't give any name. So I had to organize this information in a table. As you can see, several information about 2 different liquids are given here, vitamin information. So I need table. Liquid 1, liquid 1, liquid 2, that's my name. The first liquid has 20% vitamin C. So vitamin C and vitamin E. Those are the 2 things we are concerned with. 20% vitamin C. When they give you percentage information, write them as percentage information. And 30% vitamin E. Second liquid has 40% C and 20%. What that means is 20% of that solution will be vitamin E, 40% of it will be vitamin C. 40% and 20%, okay? How many milligrams of each should be mixed? So how many milligrams of each should be mixed is our question. So that's our unknown quantity, and we introduce names for them, and we put those names up here. Milligrams of liquid 1 to be used will be X, milligrams of liquid 2, Y. So introduce the names, and now we are ready to set up the equations. So the total vitamin C consumed must be equal to 40 milligrams. So let's write that across the vitamin C. 40 milligram should be consumed. Vitamin E should be consumed 30 milligram. Put that number there. And now our table is done. So let's calculate the total vitamin C consumed. You're taking X volume of liquid 1, 20% of that is vitamin C. So exactly how much of vitamin C is there? 0.2 X. 20% of X is vitamin C. That's equal to 0.2 X. 40% of Y is vitamin C in the liquid too. So 0.4 Y is the amount of vitamin C coming out of that. Add them up, that's the total vitamin C, and that must be equal to 40. And from vitamin E would be 30% of X will be vitamin E. So 0.3 times X is the exact amount of vitamin E you are getting from that. And 20% of Y will be 0.2 Y is the exact vitamin E you are getting from liquid 2. So add them up, that's total vitamin E. That must be equal to 30 milligrams. So that's our equation. You may want to multiply through by 10 to eliminate the fractions, and then solve by elimination method. That finishes our, these are additional exercises for you to do, but we're
I
done.
have a question.
Yeah, sure.
I have a question.
Mhm.
Over the table you have X and Y over liquid 1 and liquid 2,
Uh-huh.
but in the equation you have the X's by the I'm confused as to how you put it in the equation and how you have it on the table.
Okay, let me explain that again. X is the milligrams of liquid 1 consumed. Okay. Y is the milligrams of liquid 2 consumed by this patient. So total vitamin C coming from both liquids have to be equal to 40 milligrams. So I'm calculating the amount of vitamin C that this patient will be getting from liquid 1. X is the volume of liquid 1 he or she is drinking. 20% of that is vitamin C. So therefore, 0.2 times X is the vitamin C coming from that. Plus, vitamin C coming from liquid 2 is 0.4 times Y, right? 0.4 Y is the vitamin C coming from liquid 2. So this expression gives you the total vitamin C that this patient is consuming, and that should be equal to 40. Similarly, total vitamin E consumed is 0.3 times X plus 0.2 times Y must be equal to 30. Okay, you got that?
Yes, thank you.
Mhm. So you're calculating total vitamin C consumed and total vitamin E consumed, and that should be equal to the given numbers, 40 and 30. That's how we got this equation. Everybody's good? Any other question? Okay, then we are all set. You have, the assignment is already up. It has all these problems, and you need to remember, I went over setting up the equation, but in the homework, you had to set up and then solve and enter the final answers for each one. So if it is this problem you're solving, you find the X and Y, and the X is actually amount of liquid 1. So in the box that says how much of liquid 1 is consumed, that's where you put that number. And then how much of liquid 2 was consumed, you put the value of Y there. That's how you enter the answers. All right, so if there is no other question, we are all set. You can, you're now ready to do the homework. So enjoy the rest of the day, and I will see you Wednesday. If you have questions, hang around, others can leave.
Thank you, Professor.
Office hours at 2 o'clock. If anybody has question, you can bring it up there too. All right, go ahead, Brian.
Oh no, I just said thank you, Professor.
Oh, okay.
I actually have a question.
Sure.
For the last question we went over, you said to take it out of like the percentage or the decimal, you would have to multiply it by 10. Would we multiply the solution by 10 as well? The 40 milligram and 30 milligrams to keep it matching, or we'll leave it alone?
No, you see, when I multiply this equation, let me multiply it by 10, I get 2x plus 4y equal to 40, 2x plus 4y equal to 40, and 400 that is. I multiply it by 10. Second one is 3x plus 2y equal to 300. Now, solutions of these two equations and solutions of these two equations will be same. Okay, multiplying by 10 is not blowing up the answers by 10. Okay, the solutions are identical for this system and this system. So by solving this, I'm actually solving this system. Okay, so solution, whatever solution you find here is your solution for the original equations. That's
Okay, I just wanted to make sure if we were to also multiply the 40 and the 30 along with the equation.
Oh yeah, of course, you have to multiply both sides. If you multiply both sides, you're not changing equation. If you multiply one side, then you're changing equation. It'll be invalid equation after that. So,
Okay, thank you so much.
to keep it valid, you must multiply both sides. Any other question? All right. And
I'm sorry. Can you
yeah,
oh, it's too
go
late. You
ahead.
already you look.
No, it's
I
all
was
right.
gonna see. Okay, so how would the answer look once you solve it? I know you said we have to do the process of elimination to
Okay.
solve it.
For these two
I just
equations.
yeah, I just wanted
Okay.
to see. So we would just like eliminate either y or x, right?
Right.
And
And
then
here y is easy to eliminate because I only have to multiply second equation by -2 to be able to eliminate y, right?
yeah.
Okay. So I multiply by
Okay.
-2.
All right. Thank
Like second equation by -2. That'll make it -6x minus 4y equal to -600. That's my second equation. First equation I'm going to copy as is, 2x plus 4y equal to 400. And now if I add them, y's cancel out, and minus 6x plus 2x is minus 4x equal to 400 minus 600 is minus 200. And so divide by -4, it's equal to 50. So that means 50 milligram of liquid 1 must be consumed. Okay.
okay.
And
And
then
then that's when you plug it in, right?
now you plug in the x equal to 50 into one of the two equations. I can plug it into either one. I'm going to put it into the first one. So 2 times 50 plus 4y equal to 400. And 2 times 50 is 100. So 100 plus 4y equal to 400. So subtracting 100 from each side, 4y equal to 300. Y is equal to 7. Sorry, 7, 5. So 75 milligram of liquid 2. So that's our answer. 75 milligram of liquid 2, 50 milligram of liquid 1.